Now, let us have a little discussion about a different process: continuing nitrogen cycle, denitrification. Now, what is denitrification specifically? We know that this speaks to the conversion of our nitrates from nitrification, right, into into nitrogen gas, right? So this is primarily nitrates into nitrogen gas, right? But other types of oxides like nitrous oxides, right, in their different states can be created, right? So primarily to nitrogen gas, right? But other types of oxides can be created as well, right? Now, this usually happens this is usually the reduction of nitrates, right? So it tends to be a reduction of nitrates. So remember, nitrification would be oxidation of nitrates, well, of ammonia into nitrates and nitrites, and denitrification is the opposite, so the reduction of them, right? So this usually happens in the presence of what we call denitrifying bacteria. So we're gonna have denitrifying bacteria, all right? And a great example of denitrifying bacteria would be Pseudomonas or Pseudomonas, right? So this is also another bacterial process, right? Now, denitrifying bacteria usually transform nitrates in extremely wet and swampy areas, right, or grounds where there are little or very little oxygen, right? So we're generally looking for um, the conditions to be anaerobic, right? So this usually happens better in swampy areas, wet soil, right, where there's less oxygen dissolved, right? So they are usually anaerobic types of bacteria, right? Now this bacteria really gets the oxygen they need from respiration, right? From the breakdown, right? From the reduction, right? So it drags the oxygen from nitrates. That's how it really gets to nitrogen. So the gases that are formed will escape into into the atmosphere, right? Remember nitrogen and the different oxides of nitrogen as well, but primarily nitrogen, right? And this can be really a harmful process as nitrogen is removed from the soil. So note that that can be a problem. Denitrifying bacteria removes nitrogen. Well, sorry about that. Should be nitrogen. So denitrifying bacteria removes nitrogen from the soil. So where's the problem there? If we remove nitrogen from the soil, right? So all our nitrates, our nitrates are turning into nitrogen gas and different oxides as well, right? But primarily nitrogen gas. We know that plants, right? Plants would need the nitrates, right? So let's say that this is a this is the word plant. Plants will need nitrogen. But note that if denitrification happens at a greater rate than nitrification, the soil is going to be left without nitrogen, right? So it's not going to be pretty good for the plants. And note, denitrification happens well in wet and swampy areas where there's less oxygen in the soil. So that means that if we tend to have some things like flooding, right? or a lot amount of rainfall, right? This can increase the rate of denitrification and leach nitrogen from the soil, right? So there can also be nitrate runoff. Nitrates are actually soluble, right? So there's a lot of water. The nitrates can actually run off, right, or be completely leached from the soil via that runoff and denitrification. So note that denitrification, as its name suggests, would be the opposite form of nitrification. So denitrification speaks to the reduction of the nitrates back into nitrogen gases, right? This usually happens under anaerobic and wet conditions, and a primary denitrifying bacteria example would be Pseudomonas, right? Remember that denitrification removes nitrogen from the soil. So if denitrification happens at a higher rate or a higher rate than that of nitrification, then our plants will be in trouble.